What are we doing?
Or doing the execution environment inside of the program.
Say it again?
We're doing the execution environment inside of the same program.
Correct. So we are going to write a program where the execution environment is itself. And when we talk about that, it sounds a little strange. Obviously, you have to have some, with metacircular evaluators or with circular evaluators in general, you have to have some base platform. And from that base platform, you get to write the evaluator on top of itself. So, for example, in this case, we're going to be using Python, and Python is the language we're going to use for this metacircular evaluator. It's actually going to be relatively simple. And when you look at it, you're like, that's dumb. But it's an interesting concept. So we're going to use Python to write a Python interpreter, is what we're going to do. And so if a Python can run a Python interpreter, then when we run, so essentially what you get is you get something that looks like this. You have Python, the Python interpreter. It is running a program which is a Python interpreter. Right? Well, if a Python interpreter can run a Python interpreter, then that Python interpreter can do what? Run another Python interpreter, which could run another, and that's the reason why it's circular, because it's continually executing themselves. At some point, you are correct that you have to have something up here that is a Python interpreter that is not running Python, is written in some other language. So at some point we have some C or Java or something else, some other language running a Python interpreter. That Python interpreter then is going to be running our Python interpreter, which can then run more Python. That's the goal that we're going to be doing today. So before we do this, let's talk about the steps that we need. So what do we need to be able to do to write a Python interpreter?
Okay.
What was the steps that we needed to do to write a Lua interpreter? It's the same concept. So more than just read files. Let's make it more abstract than reading files.
Parse.
Less specific than that. Earlier in the chain, before you parse. So that's necessary, but we'll talk about that separate. Import the file was the right idea, or taking the file was the right idea. But when you're taking in the file, what are you doing?
Standard.
You're doing some sort of taking input. That's what I was going for. Not just a file, but input in general. So for example, in Python, you don't have to read a file. You can do the interpreting live. So you don't need a file. So you need some sort. So you need to take input. After we take input, what do we need to do with that input? Now you're on the right track with what we were talking about before. You need to parse it. And parsing is broken down into two steps. What are the two steps of the parser, or the lexical analyzer? What are the two steps? Sorry? There we go, thank you. Sorry, I just couldn't hear you. Tokenization and
Context-free grammar.
context-free grammar or grammar check. We'll call this just CFG. We're going to write a non-Python interpreter as well today, as well as writing a Python interpreter. But we're going to look at this. And we're going to look at doing this with the tokenization, skipping the context-free grammar step. We can see that we can approach the problem this way, but then it quickly becomes untenable in the long term. So after we do the lexical analysis, what do we need to do? There's two different parts that we need to do based upon whether or not we're writing a compiler or writing a interpreter. Right, so we have the code emitter. And the code emitter is going to be when you're writing a compiler. The code emitter is the compiled compiler. It is the machine language that the CPU can run. Compiler machine language. Otherwise, we have the interpreter, also known as the evaluator. And the evaluator is the part that makes the program work, or the language work. Fortunately for us, Python has a function that does all of these steps for us.
Yay.
Python has one function that does all of those things. So we don't have to worry about writing all that stuff. When we did a Lua interpreter, did we actually have to write a tokenizer, context-free grammar analyzer, or an interpreter? We don't have to do any of that, right? The library existed that did that for us. Somebody else wrote that. We just got to use it. And the function in Python that we get to use is called the eval function. It's a very neat function. We'll take a look at the eval function. And when we use the eval function, we'll kind of see that the eval function is how Python evaluates itself as well. And we'll see how to make it to exploit that. The same thing is true for Lua. We just use something like the do string or the do file, or we use the push and the command that told Lua to go do its stuff. I don't remember what that command is off the top of my head. pcall, I believe. So this is what we're going to be looking at. But to start with, let's start by taking some input, some tokenization, and an evaluator. We're going to skip the context-free grammar step today because the context-free grammar step is probably the hardest part to implement in terms of code-wise or algorithm-wise. This is a relatively simple problem. It sounds like this, and this sounds hard, but is not. Prior to us doing this, there's two concepts that we want to think about in Python. Python has two different kinds of basic data structures. Do you guys remember what those two different kinds of basic data structures are? Actually, it's three, but we're only going to worry about two of them.
Tables and dictionaries?
So it's a list in a dictionary. So Python has the hard brackets, which makes lists. And a list is almost identical to an array in every other language, almost identical. The difference is that the list can be expanded in Python without any extra work. You don't have to worry about being a maximum length. Curly braces in Python are dictionaries. And dictionaries are like tables in Lua in the sense that they're anything to anything. It's an anything to anything map. It's a hash table from anything to anything. Any type to any type. Whereas a list is an index to a type. Any value, any object. Any type to any type for dictionaries. Does anyone have any questions before we start doing this here? I'm going to use Replit. Hopefully Replit will be able to do all the things we need to do. If it doesn't, we'll jump over to Rogan. I'm going to use Python 3 as well, just to start with. We are going to have to search Google for some things here. So what is the thing that we're going to need to search Google for? Let me make this clear. What do we have to search Python? Search Google for with Python, the first step. Huh? Still don't know what word you said. Evaluate? Eval? Eval? E-V-A-L? Yeah, eval. No. So eval, we'll look at eval later. when we're doing it. What's the step before evaluation? Input. So we're going to let's look at Python input. Python input. Input and output, hands-on Python tutorial. Excellent. Let's go take a look. And there's also a keyboard input Python course. What does it look like we do? What is the function call that we want to use here? Looks like the function is input. What's this thing here, do you suppose? What do you think that does there? It prints that before it takes input. So this is really what kind of function? As opposed to input, it's not really just input, it's actually it's a print and an input, which is a
Scan.
prompt. Right? So it's not just taking input, it's not just printing, it's printing and it's taking input, it's prompting for input. So the Python has a built-in input. Let's go and take a look at what Replit says about that. So for example, if I come in here and I say A equals input, how are you? Over here and I hit enter, you'll see that it prints how are you, and then it's waiting for me to type something. If I type I am good, and I hit enter, it doesn't return anything explicitly because I saved that into the A variable. If I now say print A, what do we expect to show up?
I'm good.
I am good. Right? So we know how to take the input here.
Sweet.
Let's do this really simply with the eval function here. If we take a look at the built-in functions, then we'll take a look how to do without the eval function. This is the eval expression up here. I'm going to make it bigger so you guys can read it. That's too big. Hold on. There we go. Where are we going? There we go. So, what does the eval function take as arguments? How many arguments does the eval function take, first of all, when we look at it?
2.
It appears that it takes 1. What are these other things over here? Are they arguments as well? They are arguments. So what are the maximum number of arguments that the eval function can take? 3. The minimum that it can take is 1. When you see the equal sign in Python like that, those are default values. You can also do this in Java, you can do this in C++, etc., etc. It's just not necessarily as straightforward as this. In Python, when you define a function, if you define when you define an argument like so with an equal sign in the definition of the argument, that argument becomes not mandatory. You can actually, it's an optional. Thank you. Optional argument, and that's the default value. We can see that eval, when eval has globals equals none and locals equals none, it is evaluated in the local scope. So locals and globals are the scope parts that we want to be able to use. So for example, if we say x equals 1 and we say eval x plus 1, it'll return 2. So we come over here to Replit. Let's try that example. X equals 1. Oops. Let me clear that again. Try that again. X equals 1, and I'll say eval the string x plus 1, which is 2. The string that I passed here, that's just a regular text string. Eval is now evaluating it. So if I say something along the lines of A equals input, enter Python command. Somebody give me a Python command that I should enter here. Doesn't matter what it is particularly. Print A, right? So if I say print A right now, we can see that the print A is the string print A, correct? If I eval A, what should happen?
Yeah, it did.
So what is A? A is the string print A. So when I printed it, it comes out as print A. When I eval it, it evaluates the instruction, which is print A. A is the string print A. That's the reason why we see that
That
there.
was a terrible example.
That was a terrible example. Let's try another one real quick. Click here. Let's do another one. So we'll say enter a Python command. Let's say print hello world, like so. Now if I say print a, it'll say print hello world, right? Because the string is print and hello world in it. Now if I eval a, it'll print just the hello world, because the actual string is print hello world. So in this case here, A is our input that we are passing to the tokenizer, the context-free grammar, and the interpreter, the evaluator, that is the eval function inside of Python. This is essentially the definition of a metacircular evaluator. I have Python, I can write Python code comes out the other side. Yes? Raw input is a Python 2 thing that allows you to get ASCII codes. Input does not. It has less, they've deprecated raw input, is the answer. Python 3 might have some support for raw input because there's a lot of things written into it, but my understanding is you don't want to use it. That's my understanding. I might be wrong about that though too as well. It's a Python 2 thing, not a Python 3 thing. What kind of thing would I need to do such that if I wanted to make it so that only my interpreter was running? When I say only my interpreter, I don't see any more of these little tabs from the original Python environment. How should I do that? I could Google it, but that wouldn't necessarily give me the answer that I'm looking for. I have enough information so far to do this.
Tag on the input with the whatever you want your prompts to be.
Yes, but I need to make it so that I never see the original prompt again. So I need to make a while loop that never leaves this environment. So the while loop will continue to execute. Remember, so before I write this, remember I said print x? I wrote that x way before x is the value of 1, right? So just remember that x still exists inside of the global scope right now. If I say while, that's a good way to do while and forever. While true, you think that'll work? Let's try that. While true, let's say a input, and inside of this input, let's put my Python, like so.
I think it's a
Capital T. We'll see here in just a second. Then I'm going to say eval input, eval a, sorry, and I'll hit. Man. Yeah. Oh, I can't. While true, let's make this a little bit simpler to start with. Print, hello. This is probably going to backfire on me, but whatever. Yeah, there we go. And probably have to refresh the page because that page is now dead. Oh, shit. I broke Chrome. Oh, there we go. Okay. Chrome is now back. Replit. So this is always a downfall when you do stuff that's shitty, that's stupid. And all right, so now let's put that x equals 1 back into our scope. While true, true, a equals input my Python, like so, eval a. Yes. So now I have my Python prompt as opposed to the original Python prompt. Now I'm running my Python inside of Python. That's the metacircular evaluator part. When I say, for example, b equals 3, invalid syntax. Let's try that again. Let's try something else. Let's say print 3, see if that works. Maybe it's just let's try b equals 3 with no spaces there. See if that, I don't like that. Equal sign. Eval's not letting me do the equal. That's unfortunate. Maybe I can't do that with the eval. I should be able to.
What if you did it in quotes?
In single quotes, I can try that. So I can't use up anymore because I'm not in my thing. X equals 3. Print x. Right. So x equals 3. X equals 3 was the string. I'm not sure why. I must be doing something wrong about with the using the eval for that equal sign there. I'll take a look at that and I'll be able to tell you why as we go forward. I was hoping this was going to work in itself. I don't know if it's because REPL isn't letting it work, or if it's something I'm doing wrong with the eval. What's the problem? Where's this x coming from? It's in the scope, right? Now, is this the scope of the Python evaluation that I'm doing, or is it in the scope of the evaluator that's running my Python? It's the one that's running my Python, because I wasn't actually able to assign x to a value here. When we were looking at that eval statement, you can see that in the eval statement we have the ability to set the globals and the locals variable. And when we set those globals and those locals variables, that allows us to override our environment. And so when we say eval with globals and locals, that's an entirely new Python environment, or effectively an entirely new Python environment. And so by using those, we wouldn't necessarily have access to them. So let's go and come back here to the REPL. I don't know if I can actually clear this. Or we'll get back to and let me refresh that page. There we go. If I take something where if I have let's say the G environment, I'm going to just make this a dictionary. I'm also going to make L environment, which is going to be the local environment for the evaluation. If I say x equals 1, for example, and now I evaluate the string print x with the global environment and the local environment, x is not defined, because x is not a part of the global or the local environment for that evaluation of that function when I said eval. However, if I take L environment as an example, let's take L environment. Let's take global environment first. I take the global environment, and I assign the value of x to 35. Now if I eval print x, you'll see that it'll print the 35. Because the global environment for this function call contains the 35, contains the x inside of it. What happens if I set the local environment's x? Let's say 100. Now I evaluate the same thing again. Evaluates the locals. Why? Right, because we check local scope, then we check global scope. Sometimes local scope is going to have things that we like when we have a table or we have a class, we check our object, and then we check our class, then we check our parents, and then we continually go up inside of the local or even inside of the global scope. But this is an explicit example of the difference between local scope versus global scope in Python. And we can control those two scopes. Let's see if it'll let me do this x equals 3 thing here. With this. It might not. No, it's not letting me do that. I don't know why. I was pretty sure it was going to. I thought it did. Maybe Python 2 does. Anyways. Let's take a step away from the eval function. Because the eval function is pretty much straight up cheating at this point. Right? Because it's essentially Python, with the exception of the eval statement apparently. What do I do? How do I write an interpreter without using eval statement? That's the question. Well, let's write some functions that'll help us. Let's first write a function called tokenizer. What is the argument that tokenize is going to take? What is tokenize going to do, and what is the argument it's going to take? And then what is it going to return? What's the point of tokenization?
Or extend the input into different sections that can be evaluated based on their position in the string.
Right. So if I have the input string, let's suppose I have the input string here. I say A equals input, like so, and I do something like x equals 3, right? A is the string x equals 3, but I don't want to be able to, I don't have to deal with that string as one entire string. What I really want to be able to do is I want to deal with it as sets of tokens. In this case here, how many tokens would I want for x equals 3? 3 tokens. The x symbol, the assignment operator, and the 3. So 3 literal. How would I tokenize that? What's a good way of tokenizing something like that? Tokenize it based on spaces. What's that concept called when we tokenize based on spaces? Delimiters. We have spaces called delimiters. What's the function name that we want to do on delimiters? So you said cut, you said parse. There's another one that starts with S. I think it's 5 letters long. Split. Split is the generic term for this. And so if we go to Google and we say, hey Google, that's the one thing. Hold on. If I go to Google and I say Python split, and we look up the Python split, we find that Python actually has a built-in split method. You can't read that because it's too small. String.split. String, so the str, so some string.split, str is any delimiters defined, the default is a space. So if I want to be able to split based on some other delimiter, I could pass that in as the string argument and it would split on that delimiter. Num is the number of lines to be made, or the number of splits to make. So for example, if I have A, if I print A here, that x equals 3. If I say A dot split with no arguments, the default argument to string is for the delimiters is the space, and the default num is the number of possible characters in the string. If I do A dot split, I get the 3 parts. So just the split function automatically does that for me. So if I want to tokenize a string, over here, the easiest answer is just to return string.split. Now I can tokenize the string x equals 12. What is the limitation on this? If I don't use spaces, what happens? I just get that 1. Does anyone know how to solve this problem yet? Or have an idea on how to solve that? We have a dictionary of things to split on, right? I could add this equal sign. Let's put this, so I know that I can put in the string operator, I can actually put in here, I can put a couple of different things that I want to split on. Let's put the equal sign there. And let's put a space and see if this will work on both of them. So if I tokenize on x equals 12, it didn't split the equal sign there, but it did tokenize the space. Oh, it tokenized on the space equals. Well, damn, that's not what I wanted to do. Maybe if I pass it a list, oops, I didn't want to say it. Maybe if I pass it a list of tokens as opposed to a single token, like so. X equals 12, no, cannot convert list to a string not implicitly. That didn't work for me. But if I try to tokenize just on the equal sign operator, like so, then this one would split into 2, and this one would also split into 2, But that doesn't leave the equal operator for me, right? Yeah.
Is it possible to just assume that if you run the split, then the equal sign is already there, so you can just automatically assign?
Ah, I like that. Where you split on the equal sign and you say everything else is just going to be, we're just going to assume that there's an equal sign inside. Absolutely, we can assume that. The problem with that is, what if I wanted to write a different kind of operator? I wanted to say x equals y plus 3, right? Then I want to be able to also split on the plus sign, right? Do I know where the equal operator goes and where the plus operator goes implicitly? It's an excellent assumption to make. And one of the cool things about this is, who's defining this language? We are, right? So as the designers of the language, if there's a problem we don't know how to overcome, or the overcoming of that problem is overly difficult, what are we going to do? Yeah, fuck you guys, do what I say, right? Why do you have a semicolon at the end of every C instruction? Because the C designer said, I don't know how to do this well without putting a semicolon on the end of it, so semicolon doesn't mean anything else, it now means the end of line. Done. Why did the C designers use curly braces for scope? Because they didn't have an easy way to delimitate scope, and they didn't want to do any other method. They wanted a clean visual way to identify scope, so they said, screw you guys, you got to use curly braces for scope now. Right? Python doesn't do that. Python goes, hey, I don't like curly braces for scope. Guess what you have to do with your tabs now? Tab your scopes. If you don't tab your scopes, whose fault is it? Yours, not mine. So as the designer, we get to make everybody else's problems our problems, or our problems everybody else's, essentially. So I don't really have a good way to tokenize anything other than spaces, or I might be able to figure it out, but it's too difficult for now, so I'm going to say, screw you guys, you have to put a space between every instruction or every token. If you don't, it doesn't work. That's totally fine. What were you going to say?
Oh, I just kind of propose it.
Okay.
You could have a table of delimiters,
Mhm.
and then you can loop through the delimiters, splitting each substring and insert the appropriate delimiter back into the list.
Every time, right? Yeah, so that's actually the way that I would recommend doing it if we were doing this a full feature way, if we had another 45 minutes to do just the tokenizer. The problem is, you say that, you're like, oh yeah, that's the way to do it, and then you write part of it and you're like, oh wait, I have to take care of this special case, and you do that and you're like, oh shit, there's also this special case, and this one, 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 and it grows uncontrollably for a little while. So we're going to skip that step for right now. But you're right, that would probably be the easier way to do it. All right, so we have our tokenizer. Pretty simple tokenizer, right? The next step is, when we're defining the language, what kind of language do we want to define? Now this comes in, do we want to define like an imperative language or a functional language, etc., etc.? We're going to define an imperative language, but really the question I'm asking is, which of the three fix kinds of languages do we want to do? There's three kinds of fixes. There's this fix, and this fix. What are the words that go in front of here? Prefix. We call suffix, we actually call postfix. What's the third one called? Infix. Oh, that's an infix. Those are the three kinds of fixes we talk about. What do those things mean? What does prefix, infix, and postfix mean? What does prefix mean? Let's start with prefix. Before what? What does postfix mean then? After that rest of that thing, right? And infix means somewhere in the middle of that thing, right? Python is infix. Motorola 68000 is prefix. I don't think I've ever used a postfix language that is actually in use. Postfix languages are really hard to evaluate. When we talk about Python being infix, this is an example of an infix notation here. Let me make it a little bit simpler. That is an example of an infix notation. This is also an example of an infix notation. Which part of the thing is in? The what? The operator is inside the operands. So when we talk about infix, operator is inside the operands. When we learn how to do mathematics, when we learn how to do most things, almost everything we do is infix. Infix, however, has some weird problems that is very easy for us as humans to solve, but relatively more difficult for computers to solve. Let's think about what those are in a second here. What do you think prefix means then? Operator is before operands. And then postfix is operators after operands. So we say, which kind of language do we want to do? That's the question that we're asking. Do we want to do a prefix, a postfix, or an infix? Which one do you think is easiest? What did you say? Infix? Just said infix. Infix? Okay, why do you want to do infix? Because you're used to it, right? All right, let me ask you a question. Which operator do you perform first? Which one? That one over there, right? How do you know that you're going to perform that operator? Okay. Parentheses, multiplication, division, you did that thing, right? Well, in an infix notation, we have to be able to sort through the entire input, find which operators take precedence, do that operator precedence for us, right? Now, that multiply is going to be on the 7 and the 2, correct? It's not on 7 plus 5 plus 3 times 2. How do you write a loop that's going to find that multiplier and do the multiplier first? So that's just what you'd have to do. You have to write a loop that would do that. You'd also have to be able to do the parentheses before you did any multiplications. You'd have to do the divisions at the same time you did multiplications in order, and then you'd be able to do additions and subtractions and so on and so forth. Infix notation is useful for humans because we're able to look at it and go like, that one. Computers can't go, that one. Computers have to go, is it this one? No. Is it this one? I don't know, maybe. Is it this one? I don't know. 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 Look back at everything it's seen before and go, okay, I want to do this one. Do this operation. Repeat. Right? This process is difficult. So this is actually what the LR operators do when we do the context-free grammar, is that really what the context-free grammar is doing, besides being context checking for grammatical correctness, is it's determining the order of operations in infix notation. If, however, you do prefix notation, and you define prefix notation to be the order in which it's written, it becomes much simpler. For example, if I write a plus symbol here, I know that plus is going to take how many operands?
2.
I know that it will take 2 operands. I do not care what they are. I just know that I'm going to have 2 operands. If I'm going to find the value of that operand there, it doesn't matter if it requires multiple steps. I can find the, if this is the operand that I'm trying to find, I can find the value of this operand by evaluating this statement down here. Does that make sense? So I know that this entire statement is the operand to that plus. And I know this just by inspecting this plus. I don't have to worry about the rest of the things inside of it. So what we're going to do here is we're going to write an evaluator, or I'm going to suggest we write an evaluator with a prefix notation, not an infix notation. It's much simpler to write an evaluator that does that. So let's write our eval function. Let's call this eval p for eval prefix, and we don't get it confused with the eval inside of Python. Eval p is going to take what? A list of tokens, right? We have a list of tokens. Let's just worry about the addition operator first, then we can worry about the assignment operator, and we can see how we can start evaluating the language. Let's do just the addition operator. How do I know if I'm doing the addition operator? If the first thing in my list is the addition operator, that should be done. If the first thing in my list is an addition operator, that means that I am now doing addition. I don't have to worry about doing any other kind of instruction. I know that I'm going to be doing an addition on 2 operands, correct? So let's make this the very simplest step first. Let's assume that the operand will look something like this, plus 3, 7, as an example. What should plus 3, 7, how would I do the addition between 3 and 7? So what I'm going to do here is I'm going to say return list of tokens of 1 plus list of tokens of 2. That's the idea that we want to be able to do. Whatever that 3 is, we want to add it to the 7, and then we want to return that value. Correct? What might be a potential problem that we might see here? Then that list of tokens is probably a string because I took a string, right? I split that string to get a list of strings. So that might be a string. Let's see if that becomes a problem. If it is not a problem, if it works correctly, the way we expect it to, we've learned something about Python. And what that is we've learned that Python does auto-coercion. And then automatic coercion is when we coerce a string into a different data type based upon the types of the value inside of it. C, for example, or C++, for example, does automatic coercion. And when you do things like C in and C out, it'll automatically coerce things from strings into integers for you without telling you. Python, I don't believe, does automatic coercion. Let's double check that. We'll go and run that. Now we'll say eval p plus 3, 7, like so. And we get the answer is 3 there. Oh, that doesn't actually help us very much. You know what? We need to do eval p of tokenize of plus 3, 7. Gives me 37. So what happened when we added those two things together? Concatenated them, because it's concatenating strings. That's an overloaded addition operator to concatenate the strings. Does anyone have an idea on how we can convert the string into an integer? Int or integer? Let's actually take a look. Python string to, hey, look, int. It's one of the first things that we get up here. Parse string to float or int. We could actually just pass int of float or just float of a. We could probably just say eval of it. Let's give that a shot. So in here, we'll just say int, like so, of this guy, plus int of this guy. and we'll run that. So if I eval p tokenize 3 plus 7, I get 10. That's the first step of writing my interpreter. My interpreter now is able to do the addition operator as long as the two arguments afterwards are integers. So for example, if I say let's take 3.14 and add 6.28, the answer is going to be invalid literal type. Shit. How do I fix that? Let's use floats instead of ints. What if I didn't know how to use floats? I can say, oh, well, my language only works on integers. Now, you guys laugh at this. It only works on integers. But Motorola 68000 only works on integers. That's an entire CPU, right? When you think about that, you're like, oh, right. You can't do floats or floating points in 237. And you only have prefix notation. Oh, interesting. All right, so we got floats there. What if I want to be able to eval this, though? What if that's what I wanted to do? First of all, what do we expect this, what do we want this string to do when we look at it? Add the three numbers. We want to add that, which is going to be addition of these two, plus that third one over there. Correct? So what happens when we try this? We get the error because that plus symbol is not a float. Correct? So, now we want to introduce the concept of types into our language. Currently, we don't have the concept of types. We have the concept of an operator and a float, or a number, but we don't actually have the difference between the two of them. And so to introduce the concept of a type between the two of them, let's introduce the concept of a number literal. What is a number literal?
Is that where you would put like the F call float?
So yes, inside of C or Java or something like that, you would use the F to call it a float, but more specific, less specifically floats. What if I just wanted to say the number 3? Is that a number literal? For example, if I type 3, that's a literal. That's a number literal. I hit enter, hey, it's 3. If I type in 3.14, that's a number literal. So we want to be able to have this kind of thing. Now how do we know if it's a number literal? In Python, how do we know if the thing that's given to me is a number literal? What's the easiest way? We've already seen it. Try to convert it into a number literal or a float. That's the definition of a number literal for us so far. So for example, if I say float of the string 3.14, I get 3.14, which is the number literal. If I take the float of 3.14 as the number literal itself, I still get 3.14. If I try to take the number literal of the string x, it fails. What's this thing happening right here? What is that? It's an error. What do I do about errors? What's that called? What's a try-catch? Error checking or exception handling. So let's go Python try-catch. Errors and exception in Python documentation. In fact, it's 2.7 doesn't particularly matter. Do that stuff. It says, oh, invalid syntax. Exceptions. These are all the different kinds of exceptions we can catch. Handling exceptions. Try catch or try accept. It's not in the catch anymore. It's just a try accept, like so. Oh, okay. These are the different kinds of errors we can get, right? What's the error that we got here? Value error. So if I try, let's try. Did I need a colon on try? I do need a colon on try. Let me clear this first. If I try colon float of x, what does the rest of it look like? And then I accept, accept, what do I want to accept on? What was the kind of error I got before? Value error, right? So I can accept on the value error, like so. Let's go ahead and print not a string or a number literal. X is not a number literal. Correct? Cool. If I come back over here, I want to be able to evaluate, the idea here is I want to be able to evaluate a number literal to a number literal. So for example, if I type in 3.14 and I hit enter to my evaluator, I should get 3.14 back. How do I check to see if I got a number literal? How do I check to see if I got a number literal? I try it. If I get a number literal, what do I want to do? Not necessarily add it. So it's not necessarily that this is going to be adding here. What I want to be able to do is I want to evaluate a single number literal, so I can type 3.14 and have that single number literal return 3.14. So I'm going to do here, I'm going to say try return float of list of tokens of 0, and we're going to accept on the value error, like so. In the case of a value error, what do I want to do? Currently, I'm going to try to evaluate the rest of it. So I changed what I did here. What did I do, and why is this going to help me? I meant to say not eval. ELP. What is my evaluator doing here?
Oh.
If it's a number literal, what do I do? I return the number literal. If it's not a number literal, I evaluate it as if it's not a number literal, so to be something else. And so that's going to give me the plus sign, which would be an operator for me to be operating on. So if I can operate on that plus sign, I'm going to evaluate the next thing in my list. And then what that's going to do is it's going to figure out if it's a number literal or if it needs to evaluate to make more things happen. Currently this is a little bit buggy, it doesn't work exactly the way we want it to. But if I say eval of p of tokenize of the string literal 3.14, it's going to return 3.14, which is the number literal that I was asking it for, because it's able to find that. Now if I say eval of p tokenize plus 3.14, 6.28, it'll give me the correct, didn't give me the correct answer quite, did it? 9.28, should be 9.3 something. Well, I don't know why that happened, we'll figure that out later. Got 9, which is okay. Now if I take, let's just use integers for now. If I take plus 6 and 7, what's going to happen? So we first evaluate this plus because it's not a number literal. Then we try to evaluate that 3, which is a number literal. Then we try to evaluate that plus sign there, which is a recursive call to evaluate. That plus sign is not a number literal. And so we think it's going to say plus, it's going to take the plus and the 6 and the 7, but it's actually going to give us an error. And the reason why is because what we're giving it is just the plus. What do we really want to give the eval function? The rest of the thing, not just that part of it. That's where we're going to use the slices. So let's take a look. If I have a equals plus the string plus 3 plus 6, 7. If I take a of 1 and everything, and with the, that gives me the 3, the plus, the 6, and the 7. If I take a of 2, that's okay. That's the part that I want to do. So I'm going to use the slice with the colon operator after the 1 and the slice with the colon operator after the 2. That's going to give me the ability to take the entire string afterwards, and I should be able to now do this to get 16. Why is this working?
Wait, what did the colons do again?
The colons do a slice. They say take the rest of it after that number. So for example, we're going to skip one element and take the rest of the array. We're going to skip 2 elements and take the rest of the array. And so if the token, so for example, if we say tokenize of plus 3 plus 6, 7, right? Let's assign that to a variable. Let's say a equals that. If I say a of 1 colon, that gives me everything after that first plus, right? If I say a of 2 colon, it gives me everything after the second element, which is the plus 6, 7. So we can see that the eval p of 1 colon is evaluating that 3 successfully and returning it. The eval 2 colon is evaluating that plus 6, 7 successfully and returning it. It works through recursive evaluation of the expression that we're asking it to evaluate. Let's try another evaluation with the tokenize right here. Is this going to work? We assume that this is going to return what? 16, because 3 plus 6 plus 7 is 16. But it returned 19. Why did it return 19? So first we did the plus, right? Which gave us the 1 colon. The 1 colon is the plus 6, 7. So we evaluated plus 6, 7. Plus 6, 7 is 13. 2 colon is the 6, 7, 3. That's 6 was then evaluated as the token and returned as 6. So we added the 6 in twice to get 19. What's the problem?
It has to be broken up first way.
What do you mean by it has to be broken up the first way?
The way it's typed out has to be plus number plus.
So we could either define that it has to be broken up the first way, or we could try to fix this problem here. How could we fix that problem? The answer is we need to, as we evaluate the function, we need to consume the operator, or consume the input. Currently, when I say eval p list of tokens 1 colon, do I consume the list of tokens? Because list of tokens here is the same as the list of tokens here, right? What does consume mean? Right? How can we discard something if it's a list? Just remove it, right? So if I had a list, for example, A. Let me clear this. If I have a list, for example, A. If I wanted to discard that first part of it, how do I discard that first part of it? How would I make A, or get rid of that first part? So 1 colon, right? That would discard that first part of it. How do I permanently discard that from A? Now if I look at A is permanently discarded. If I write a function on A, and we say here A equals A of 1 discard, but I don't return it. If I have my A does not exist anymore. Let's make B equal tokenize of the string. So B is this string now. If I call discard token on B, is B going to be modified? Is that B variable going to be modified?
Yes.
So we say, so we have a yes. Is it always going to be modified for all languages? When would a language not modify that? If the language is passed by value, that means that we would copy this B into that argument such that this entire thing would be a copied array, or that copied list. And if I modify that list inside this function, I am not modifying this list outside of this function. That's if we're passed by value. If we're passed by reference, that means that the B there and the A there are the same table. They're just pointers to them. If we're passed by value and we pass a pointer like we do in C or C++, then we have to worry about that whether or not we're passing by value or by token, by pointer. What's the answer? Python is passed by value, right? If this was a pass by reference, it would be better. Let's find out if Python has a pass by reference ability. Python. Pass by reference. How do I pass a variable by reference? Stack Overflow. Arguments are passed by assignment. The rationale behind this is twofold. Passed by assignment. We read this, some data types are mutable, but others aren't. So you pass a mutable object into a method, the method gets a reference to that same object, you can mutate it to your heart's delight. If it passes an immutable object to a method, you still can't rebind the outer reference, and so you can't even mutate that object. Let's try to modify it. So this is the example of the code here. Try to change the list contents of the list. Append 4 to it. The outer list is 1, 2, 3. Print with it. Try to change it and print it again. Change to 1, 2, 3, 4. What ended up happening here? What does this say about lists? What's the implication here? List is mutable, right? We should be able to change that list. So why did this not work? So if lists are mutable, and it's true that lists are mutable, why did this not work, is the question. What was yours? We don't have to return it. That's not the answer. When we say A, when we take a slice of a list, we are generating an entirely new list from that original variable here. And then we assign it to the local value A. We did not modify the past list. We just took a part of it and reassigned it to a local variable. So instead of using a split or a slice, what do you think we could use instead? What from here, what kind of hint gives us a hint about how we can modify that list? That append, right? If there's an append, there probably is a discard or something like that, right? So what we do is we come in here, we say Python list discard, delete. Let's see, there's a delete. There's a delete. Python list delete, remove. Right? And so it removes this particular element. I don't necessarily want to remove a particular element. How to remove an element from an list by index? Stack Overflow. Del. Ooh, that's an interesting function. There's a function called del on A. Let's see if that works. So if I delete A of 1. Yes, so you can absolutely do that with Python. It means the last element.
Last element of the first element?
The negative 1, so 0, or 0, oh, we want to del 0. 1 A of 0, not A of 1. So 0 is the first index. Negative 1 would be the wrapped around to the opposite side.
Oh, here's the last
Let's try that discard token now. So we have B. B is not defined. I guess every time I do that, I redefine the B. B is that tokenized, so B is this. Now if we discard token from B, and we print out B again, neat. So B is mutable. And so that will allow us to mutate B. So how do we want to change our eval P to be able to do this? We're almost out of time, so I'll just kind of show you here. What we can do here is we can actually, before we return here, we can get the value we want. Val to return equals this. We can del P, or del list of tokens, or actually we don't have to del, we just call discard token on list of tokens. Like so. So we discard that token and we return that value. There. And then we should be able. Still 19. Oh, because before we do this, we actually have to discard our token on list of tokens. When we do that, though, it makes this slice different. We actually pass the entire list of tokens to you. Is that correct?
No.
No. Damn. So we still have a bug somewhere inside of here, but this is the general idea behind an evaluator. Evaluators aren't particularly, I mean, they're complex. When we go, we have to, write the circular recursive function, but they're not particularly complex. Essentially, if there's an operator for me to perform that operator on some data. But that data might have to be evaluated before I can operate on it. So this is essentially the way that we write interpreters, is this thing right over here. But this gets very complex over a short period of time, and it doesn't allow us, what if I want to now add minus, as an example? I have to write an entire one of these guys, or multiply, or another kind of literal. For example, a string literal, or variables. All of those things take another level of difficulty to add to this kind of interpreter, and that's where we start to get into things like context-free grammars before we do the evaluator. Because the context-free grammar gets rid of a lot of this garbage that we don't know how to take care of. It makes it easier for us to do. All right, the homework assignment it's not posted yet. It will be posted in a little bit. It is to tokenize input strings and then to make them and to pass them as literals. And so you have to take things and turn them into two kinds of literals. They're either going to be number literals or string literals. And then you're going to keep the value inside of yourself. And then those token objects will be passed to a context